I've just started the recording. Hello everyone, thank you for joining me today for this training session. I'm not sure if you've met me before, but I'm Holly. I'm the new head of geoarchaeology at Cotswold Archaeology. So I'm just going to share my screen. Hopefully you'll be able to see the presentation.
Yeah.
Can everyone see that?
Yep, can see that.
Yeah, okay,
Yeah.
brilliant. So today I'll be delivering a session on geoarchaeology and reconstructing past environments through subsurface investigations. So first of all, introductions. I'm Holly. I thought it'd be a fun activity for us to introduce ourselves. I know we work for different departments, so it might be that we haven't worked together before or don't know anything about each other outside of working hours. So as I said, I'm Holly. I recently joined Cotswold Archaeology as the new head of geoarchaeology. A couple of facts about myself. I love gardening and doing crafts. I recently attended a pottery painting workshop and made my own Christmas wreath. So Anne, do you want to tell us a bit about yourself?
Yeah, I'm Anne. I'm new to geoarchaeology because I've spent my whole career in early years childcare and education, so I'm making the change. Some interesting things about me. I used to play the saxophone very badly and very loudly. And I like watching films, a particular big fan of Elvis.
Lovely, thank you. And Richard?
Hi, I'm Richard. I'm a chartered landscape architect. Yeah, I'm new to geoarchaeology as well. Couple of fun facts about me. I am an avid koi keeper, massive garden fan as well, obviously being a landscape architect. And yeah, love to travel.
Brilliant, thank you. The learning objectives of today. So it's good that you're both new to geoarchaeology. So hopefully by the end of this presentation, you'll have a greater understanding of what geoarchaeology is, what the role of a geoarchaeologist is, the type of work geoarchaeologists undertake, and how subsurface investigations can help to reconstruct past environments. So firstly, what is geoarchaeology? Do you have any initial ideas or thoughts? If you could use the chat box on Teams to put any initial ideas you have. Yeah, that's great, Anne. So archaeology of the earth and boreholes, yeah.
Yeah.
They're definitely involved in geoarchaeology.
Just that I've heard of them before, so I know it's something that you do.
See, Richard is typing.
Okay. Pop
Yeah,
my
the
answer
study
in
of
there as well.
thank you. The study of archaeology and geology and landforms. Yeah, brilliant. So they are all elements involved in geoarchaeology. Essentially, geoarchaeological techniques can be used to reconstruct past landscapes, so we can understand how humans may have interacted within their environment in the past. I like to analogize it like a layer cake. So sediments build up on top of each other over time, with the oldest sediments typically being towards the bottom of the borehole or the cake, and the younger deposits that have been most recently deposited would be towards the surface. So by investigating these sediments, looking at the types of sediments present, what inclusions there are, we can build up a picture of how that environment has changed and where we're most likely to find archaeology, where it's most likely to be present. Some deposits preserve archaeology if it's present better than others. So archaeology can be found in any sediment type. Some deposits, such as alluvium and peat, are great preservers. They're typically anaerobic, so the absence of oxygen means that it acts as a barrier, sealing and preserving the archaeology from decay. So if we have these deposits present on a site, that's great for geoarchaeologists, because if there is archaeology, it's likely to have really good preservation, and we can use this through examining these deposits to reconstruct past environments and assess the potential of the archaeology and the geoarchaeology of the site. Now, how can we reach these deposits? Sometimes they can be at great depth. They can be 10, 20 meters beneath the surface. So how can we get to them? If you think of like an apple corer, borehole cores apply a similar technique in that with the apple corer, you're pulling out the core of an apple outside of the apple, so you can see everything that was within in situ, but externally to the apple. It's the same with boreholes. So boreholes drill beneath the surface and they lift deposits from depth above the surface, and you can see all of the different stratigraphical layers as they've been laid down beneath the ground, but in situ. So what is the role of a geoarchaeologist? Primarily, it's split between field work and desk-based work. In terms of field work, this might involve working in support of archaeological field investigations. So we might carry out site visits to advise on sampling strategies, or take geoarchaeological samples through sections and features, as shown in the photograph here. So this is a monolith sequence taken through a profile of a feature on site. So conduct geoarchaeological surveys. So these would be geoarchaeology-led fieldwork projects to acquire sediments from depth to inform on the environment and past landscapes. This could involve test pit surveys, borehole surveys, hand auger surveys, and we would be there leading the field work and obtaining the sediments for geoarchaeological analysis. We might also monitor geotechnical ground investigations. These would be engineer-led fieldwork projects, where the engineers would already be on site to undertake borehole surveys to inform their development or the structural design of their proposals. Essentially, we're interested in the same data, so it saves time, rather than geoarchaeologists having to go out to site weeks or months later to drill boreholes in essentially the same locations to acquire the same data. We can work together to record the location, so elevation and coordinates of the boreholes, record the geology present, and take samples on the same projects at the same time. Now, desk-based work, this involves producing geoarchaeological assessment reports and deposit models. So this would be using the data that we've acquired in the field, we'd be assessing it, interpreting it, writing up reports, and then producing deposit models using industry standard software to model 2D and 3D outputs of these deposits. So here we've got an image of a borehole core that's being assessed in the laboratory, and by recording the types of sediments present, the upper and lower boundaries of each sediment unit, we can input this into the software to produce deposit models such as shown here in transects, cross sections, that type of thing. The main deposit modelling outputs involve digital elevation models. So here we've got the red line boundary for the site shown, and by inputting that sediment data into the software, we can map the upper surface elevation across the site. So for instance, here you've got glaciofluvial deposits mapped within the site. These data points would have spanned the entire site, so it would have covered the whole site boundary. But from the data, we can see that it's only in this kind of central southern part of the site that this particular deposit is present. So that we could produce similar models for any deposit across a site and we peel back the layers and select ones that have geoarchaeological potential to model just that specific layer. So if it was peat, alluvium, and as I said here, it's glaciofluvial deposits, we can identify where exactly in the site they're present and where they're likely to be impacted. So if we know how deep these deposits are beneath the ground, by modelling the upper surface of where they appear, we can understand how the proposed development might impact those sediments. So for instance, if it was a high-rise block of some sort, and they were doing deep piling foundations, we could know the depth that the piles were going to, and we can see where the upper surface of this particular deposit appears beneath the ground, and we can see, is it going to be impacted by the development or will it be fine? Alternatively, if it was a solar farm, for instance, it has very limited minimal impact beneath the ground. So it might be that the ground will only be disturbed for the first half metre, and if there's deposits that lie beneath that level, then they wouldn't be impacted at all. Likewise, we can do thickness plots. So for particular deposits across a site, if we wanted to map, for instance, the thickness of peat across a site, we could say, okay, the areas that are in the dark blue have the thinnest deposits across the site, and the areas in the deep brown are the thickest. So if we were going to target further work or recommendations, we could say, okay, well, in the northwestern corner of this site, we've got the thickest deposits of peat present. That's where we want to target our investigations. So if there was going to be a watching brief of the ground investigation works, we might target our monitoring and recording to this area where we're going to get the most amount of geoarchaeological data, as opposed to areas of the site where there might be, you know, a couple of centimetres or half a metre. If you've got, could be here, you've got 4.6 metres. So we want to target our investigation to get the thickest, most complete sequences that give us the highest chance of getting those paleoenvironmental indicators such as like pollen, snail shells, waterlogged plant remains that can give us the most amount of data to reconstruct the environment in the past. And subsurface transects or cross sections. So for each of the boreholes monitored, you can see beneath the ground, you can map the different deposits present. So here we have a transect that was in a coastal location. So it was across geotechnical boreholes. The coast was more towards the west of the site, and going further east, it was more inland. So here in orange, you could see there were storm beach deposits. So as you might imagine, these would be kind of large kind of gravels, you know, the types of deposits you'd expect to find at the beach, a stony beach, you know, gravel deposits that have been upcast by wave action and created a kind of storm beach deposit barrier, behind which, as we're going further inland, we found more alluvial and peat deposits. So the storm beach deposits here have provided a barrier behind which water and plants have accumulated, and vegetation, and it's provided an environment conducive for those deposits to form. So by understanding the location of these boreholes in their current environment, but also looking beneath the surface and understanding, how did these deposits get there? Why are they there? Do they have significance? And what do they tell us about humans in the past, where they may have lived, or the environment around them? It can provide us a lot of information. So hopefully you'll have a clearer understanding about what geoarchaeology is, what the role of a geoarchaeologist is, and the type of work that we undertake. Also how subsurface investigations can help to reconstruct past environments. I'm going to do a quick poll via Teams just to see how your understanding has improved. Did that come through for all of you?
Yes, thank you.
Just filled it in. A really interesting presentation.
Did you get that, Holly? The boats?
Yes, it's just come through. Thank you. Yeah, so thank you for filling that in. I've got 2 responses, and both of you have said that you have a greater understanding of geoarchaeology following this training session. So that's fantastic. Do you have any questions? Is there any questions for me that you have?
How long has it taken you as a career to get to where you are?
I've been working in geoarchaeology for over a decade now. So yeah, started out as I undertook a undergraduate in archaeology and became a field archaeologist for a couple of years, and then did a master's that enhanced my understanding more about geology and environmental hazards before starting out as a geoarchaeologist and combining my 2 interests in geology and archaeology into geoarchaeology. And yeah, I've been working in the industry over a decade now, starting to build up a new department at Cotswold in geoarchaeology, offering these services and starting to grow the team. Is there any other questions?
No.
Brilliant. Well, thank you for attending today. I hope it's been useful. It's been lovely to meet you both. And yeah, get in touch if you have any queries or if there's any upcoming projects that you think geoarchaeology could provide any input, then let me know.
Thank you. That was really interesting. Thank you.
Yeah, thank you. It's really interesting to learn about the boreholes and the process in general, and just how the whole profession works, really, from start to finish.
How
Really
many different
interesting.
parts there are to it? Yeah.
Yeah. It's really opened up my eyes. Thank you.
Brilliant. Thank you very much. Bye.
Thanks. Nice to meet you, Anne.
Bye.
Holly.
Bye.
Bye. Bye.
Bye. Bye.